Good afternoon, good evening, or good morning, ladies and gentlemen. Welcome to the second of our webinars today, looking at stainless steels for safe and sustainable electric buses. My name is Tim Collins, and I'm the Secretary General of the International Stainless Steel Forum, and I have the pleasure of introducing one of our fairly new members of staff, Mr. Frank Sujuk Yoon. Originally from South Korea, will be presenting this afternoon's webinar. So in a moment I will back out and allow Frank to take center stage, but I thought it was worthwhile introducing the session today. We do look forward to everybody's participation, and thank you very much for joining. So at this point in time, I will take a back seat and allow Frank to excuse me, just take you through the presentation and introduce himself. So Frank, over to you.
Thank you, Tim. Welcome to today's International Stainless Steel Forum webinar titled Stainless Steel for Safe and Sustainable Electric Buses. Once again, my name is Frank Sujuk, and I am the presenter of today's presentation. Before I proceed, one side note, this file, these presentation notes, they're going to be shared by the participants of today's presentation. So if you happen to maybe miss a slide or you didn't quite get it, everything will be shared. In addition to that, not only the file, but also the recordings of it will also be uploaded on YouTube. So for later on, whether it's for yourself or your colleagues, whoever wants to see it again, it's up there, so there's no worries on that. Now, before I jump in, a little bit about myself, because you're probably wondering, who is this guy talking? Once again, name is Frank Sujuk. I'm a fellow at the Market Development Committee at the ISSF, and prior to being posted here, I was with POSCO and had 13 years of commercial experience in stainless steel. 8 of those years were spent in South Korea, and 5 of those years were spent at POSCO's plant in Turkey. As of now, at the ISSF, I'm responsible for 3 projects, and one of them is what we're going to deal with today, stainless steel on electric bus frames. Okay, so let's jump in. Now, today's webinar is going to be like a story, really easy story, so I'll jump right into it. First of all, I'm going to start off with the environment that we are in right now. With regards to electric buses, or buses just in general, what sort of environment are we in? And with that in consideration, we follow by what is the market size, and what are the advantages of an electric bus? Now, assuming that we are going to make an electric bus, we will have a variety of options with regards to raw material, our feedstock. So I'll follow that with what sort of feedstock do we have right now? What choices can you make? Then, upon selection, we'll have to make the bus. So that'll be followed by where stainless steel can be used on an electric bus. That comes next. We'll have a stainless steel tonnage forecast. And because today in the audience we have several folks from the stainless steel community, what sort of tonnage do we forecast with regards to electric bus? Then, since we know where we use it on the bus, how much tonnage it is, then where's the right address? In other words, what are the stainless steel supplied by the ISS members? And that'll all be concluded by a summary in the end. So, for the environment, where are we right now? Well, greenhouse gas emission is one of the biggest problems in cities. Now, transportation is a major cause, and if we look at the ratio, 28.2% of total greenhouse gas comes from transportation, just one factor. And on top of that, the cities that we're living in, they're becoming larger. The population is growing. Naturally, pollution is increasing. And if we look at the percentage of population in urban areas, as of last year, more than half of the world's population lived in cities. And as the years go by, this number is expected to increase to 68% come 2050. Now, I'm sure that if we look at the pictures below, everybody has seen the tailpipe of a bus. It's one of the major causes of greenhouse gas. It's noisy, it smells terrible. We've all seen that. But also at the same time, do you know that the masks that we wear, because of COVID, but these masks were here actually before COVID, and the reason was just to breathe fresh air, just to breathe clean air. It's been too long since we've had these masks on, and it'd be terrible if we had to have these on for the rest of our lives. And this is one of the reasons why this pollution, this greenhouse gas problem, is getting bigger and bigger. Because of that, governments in the world, they're implementing regulations on greenhouse gas. And because of these regulations, the bus manufacturers have to comply not only to the regulations, but also cut down on costs in order to stay competitive, which is very challenging because if there's regulations, chances are your costs are going to go up, but you can't do that. You have to make sure that they go down in order to stay competitive. So what are some examples of these regulations that we're talking about? There are many, but to name just a few, let's take a look. The United Nations, their target is to cut global emissions by 7.6% every year for the next decade to meet the Paris target. In addition to that, not only the UN, but the European Commission, the US government, the Chinese government, and essentially every government in the whole world. They all have their individual targets to make sure that greenhouse gas is reduced in comparison with today's standards. Naturally, this means that because of all these regulations, this paves a way for growth of the electric bus market. Okay, so it paves a way. Now, how much of a market are we talking about? And this is the picture. In 2019, worldwide, there were 420,000 electric buses in the world. Okay, what do we see in the future? 2025, the number will jump 59% to 666,000 units. And 5 years from there, 2030, the number will jump even more to 888,000 units. Now, compared to 2019, the market will double, it becomes more than double. It has huge potential, this market. And you can see that on the chart below. The chart below shows what the market will be, the market forecast on a yearly basis, and also on a regional basis. Now, if you look at the chart, you can find one funny thing, is that one particular region has most of the pie. That's China. Now, it'd be a good thing to see why China is where they are right now and how they got there. That way we can learn what we need to do in order to make sure that we keep up to the standards. What are the reasons? There are many reasons, but to name the major reasons, first of all, it's China's electric vehicle market is central planning. Now, what that means is that these policies, they're made from the central government, they come down on a top-down basis, and naturally, because the central government is in the core of all of this, they have made regulations, they have made subsidies to make sure that the electric vehicle, electric buses, these flourish. For example, a license cost, it costs significantly less to get a license for an electric vehicle as compared to the conventional internal combustion engine. And on top of that, not only the central government, but multiple parties are involved in this operation. The central government, national level, the municipality level, there are multiple parties in here involved to make sure that the electric vehicles, electric buses become more flourished. Second of all, the market is very large. Everyone knows that the Chinese market is large. And because of that, the manufacturers, they don't need to concentrate too much on the competition itself. Rather, they just need to concentrate on the production and supply to the market. And the third one is the installation of infrastructure, the charging stations. The authorities have built several large-sized charging stations for electric buses. Thus, the accessibility is very easy. Now, we're right now in 2021, and all of this first started 20 years ago. In 2001, it's the first year when the central government decided that electric vehicles should be the next item in the future. And for 20 years, they've installed all the infrastructure, they've got the policies in place, and that's one of the reasons why they are where they are right now. To get a clearer picture, let's do a simple comparison. Now, this slide shows 3 cities in the world that have similar land area, more or less similar population. And from this comparison, you'll be able to get a clearer picture of where they are. The cities are Shenzhen, China, Moscow, Russia, and Buenos Aires, Argentina. First of all, for Shenzhen, the land area is 2,050 square kilometers. Population is 12.5 million. The number of electric bus is 17,000 units. The number of charging terminals is more than 1,700. Now, in contrast to that, Moscow, actually a little larger in land area. Population, almost the same, but the number of electric bus, the number of charging terminal, significantly lower. On the right, we have Argentina, Buenos Aires. Land area, population, you can see that, but the number of electric bus, the number of charging terminal is even less. So you can see in this picture where they are right now. And by the way, the number of electric buses in all of Europe as of 2019, 4,000 units. All of Latin America, 1,229 units. And all the United States, 650 units. So you can get a grasp of where they are right now and where the rest of the world is. But if you flip it over, it also means that this electric bus market holds huge potential for us. So now that we've seen where it is, what are the advantages of an electric bus compared to a conventional diesel one? Aside from the part that there are environmental regulations to comply with, what are the advantages? Well, there's namely 3. First of all, the environment aspect. Second of all, the noise. And third, the cost. So let's take a look at them one by one. The first one, environment. Essentially, it means the gas emission. So let's compare how much gas is emitted on basis on which engine we use. The chart here shows the CO2 emission on accordance to what sort of engine that bus uses. In this case, we have diesel, natural gas, diesel hybrid, and battery electric. Now, if you check the charts, you can see that battery electric, the CO2 emission is significantly lower, 60% lower than a diesel bus. And bear in mind that the only reason that there is any CO2 emission at all for a battery electric bus is because this chart has taken into consideration the CO2 that's made when the electricity is generated in the United States. It took the average electricity mix. So if we deduct that factor, the difference between a diesel bus and an electric one is bigger. Next, to the noise. Now, this chart shows the sound pressure level and the speed of bus with regards to a diesel bus and an electric bus. And you can see whether the bus is stationary or whether it's moving at 10, 20, or 30 kilometers per hour. What happens is that the sound difference, the diesel bus is almost 2 times louder. And not only in numbers, but you can see this, you can experience it for yourself. If you go out to the street and if you see a diesel bus passing by, it's very loud, not to mention smelly. Electric bus, it's quite quiet. And that's the reason why that sort of experience, if you quantify it, we can get this sort of chart. And by the way, I want to mention that, yes, there is some sound, there is some noise generated from an electric bus because it is a bus. The wheels roll around, there is the sound of electricity. But overall, you can see that there's a huge difference. Next, to the cost. Now, this chart is a very simplified version of a cost comparison of a diesel bus and an electric bus. Now, for the sake of calculation, both buses were made of carbon steel. Let's take a look. For the unit price, yes, the diesel bus is cheaper. Battery price, electric bus has a battery, so there's a cost there. But the next 2 elements, the fuel expense, the maintenance cost, it's uncomparable. And if we add these elements, and if we do it on a calculation that the bus is used for 12 years, which is actually the average years of a bus that's used in Europe, the total cost between a diesel bus and electric bus, there's a 27% difference, which is very significant. So we understand the advantage of it. So if we understand the advantage, we want to make an electric bus. Now, one of the first things you do is you select a raw material. And when you select your raw material, your feedstock, well, there are many aspects to consider. And these are the major ones. First of all, the safety aspect. Is this raw material, does it ensure safety? The second one, maintenance. Do I have to keep on repairing even after installation? The third one, longevity. How long does it last? And the fourth one, of course, very important, cost. How much does it cost? And if the numbers don't add up at the end of the day, then it's going to have limits. So let's look at the cost as well. Now, with these aspects, what options do we have? Well, we have, first of all, carbon steel, which is pretty universal. We have aluminum, and we have stainless steel. And before I go on, I want to explain a little bit about stainless steel so that we're all on the same page. First, regarding the definition, what is stainless steel? Well, it's a group of iron-based alloys that contain minimum 10.5% chromium. And this 10.5%, or actually minimum 10.5% chromium, is what makes this material stainless. You can see on the picture below that we have the stainless steel substrate. We have the passive layer, which is created by this chromium. That prevents the stainless steel to have exposure to oxygen, thus makes the material stainless. From this, we can see that the key alloy elements are, of course, chromium. But also there's nickel. And nickel, if you add it, it improves ductility, provides cryogenicity, improves weldability, and stabilizes austenite. Now this stainless steel, it's constituted of 4 families. The names are austenitic, ferritic, duplex, and martensite. And essentially, what divides them into these 4 types is how is the cubic structure made? First of all, for the austenite, it's a face-centered cubic structure. In other words, the iron atoms, they're on all cube corners and all faces. Now this makes it the austenite material to have high ductility, easy to form, has good corrosion resistance, and is non-magnetic. All right. What about ferritics? It has a different structure. It is a body-centered cubic structure. In other words, the iron atoms are on all cube corners and the center of the cube. This makes it reasonable corrosion resistance. Less than austenitic, still reasonable corrosion resistance. Easy to form and weld, and it is magnetic. Next, the duplex. It's a mixture of the austenitic and the ferritic structures. This makes it to have high strength, excellent corrosion resistance, good ductility, and good fatigue strength. And finally, we have the martensite material. It's a body-centered tetragonal structure, enabling to have high tensile strength, modest corrosion resistance, and it being magnetic. So now that we've seen what families are in the stainless steel structure, let's compare them with carbon steel and aluminum. This chart shows the characteristic comparison of the materials that I've explained. And by the way, the color codes, they show the performance of each material in relative comparison. So for example, green would mean good, yellow would mean fair, and red would mean poor. Now we can see the comparison of these materials from a strength, corrosion resistance, weldability, appearance, energy absorption, fire resistance, service life, and life cycle cost. Now, not for all of them, but for the majority of them, you can see that stainless steel has the upper hand when you compare it with carbon steel and aluminum. For example, strength. We know that aluminum is the weakest. Corrosion resistance, Carbon steel, yes, it's very vulnerable to corrosion. Weldability, more or less the same. Appearance, this actually goes in part with corrosion resistance. Carbon steel has the most poor numbers on it. Energy absorption, ferritic, stainless steel, and aluminum, not so good. Fire resistance, aluminum has the lowest mark because aluminum, the melting point is the lowest. Service life, this also goes in hand with corrosion resistance. And finally, the life cycle cost also shows a similar picture to service life. So you can see on the characteristic comparison, in most factors, stainless steel holds the upper hand. Now, this is a very generalized comparison. Now, I want to go a little bit more in detail into some of them. First of all, with regards to the safety aspect, as I mentioned before, how safe are these materials? Now, we're going to use a stress strain curve comparison. And what this is essentially the relationship between the stress and strain. So you obtain it by gradually applying a load of test coupon and then seeing how it changes. Now, as the previous slide, we have carbon steel, we have aluminum, we have stainless, austenitic, ferritic, and duplex. Now, you can see that each chart has a curve, and that curve states the yield stress. And you can also see that each chart has an area in pink, which means the energy absorption that's possible for these materials until the point of fracture. Now, if you compare the charts on the top and the bottom, you can see that for the most part, stainless steel holds a larger energy absorption area as compared to carbon steel and aluminum. Next, for the corrosion part. For corrosion comparison, we're going to use PREN, which stands for pitting resistance equivalent number. Essentially, what it means is the higher the PREN, the better performance it has with regards to corrosion resistance. And this chart below, we can see that on the x-axis we have PREN, and on the y-axis we have 0.2% proof strength. And what this means is that this chart places yield strength and corrosion resistance against high chloride environments for grade consideration. Now we can see that there's duplex here, there's ferritic, there's austenitic material, and we have carbon steel as well. For duplex, we can see that duplex stainless steels provide both high strength and high corrosion resistance. The other ones, austenitic and ferritic, not so much. Carbon steel is way back there, and PREN cannot be calculated for aluminum. So from this chart, for most part, the duplex has the highest points, and then followed by austenitic and ferritic materials. Next, for service life, on an urban setting, let's see how long they last for carbon steel, or aluminum, or stainless steel. Now, carbon steel, yes, it has the shortest lifespan. Aluminum, a little longer, but not so much when you compare it to stainless steel. Stainless steel obviously has the longest service life. Now I'll jump into the life cycle cost. Now, with regards to life cycle cost models, there are countless numbers out there, and it depends on which one you use. But for our calculation, we used one that was made by one of our members, the Southern Africa Stainless Steel Development Association, also called SASTA. They have their model here, and we used it to see a comparison of how much life cycle cost is calculated from stainless steel and other materials. And by the way, on the appendix, I've made a page that shows how to get this life cycle cost model made by SASTA. It's actually an application. Anyone can download it and use it on their mobile and use it on their laptop. It's free of charge, it's available. Now, this model, let's see how it's made of. It's made of initial cost plus operating cost, and thus that makes total cost. The initial cost is constituted from three elements: material cost, fabrication cost, and other installation costs. Now, what do they mean? The material cost means the cost of the material itself. The fabrication is the cost of fabricating, cutting, welding, forming. And we have other installation costs, which is essentially the cost of surface protection, special labor skills. So for a surface protection, usually it would mean to painting costs, epoxy coating costs. For special labor, any additional cost that occurs for employing specialists that are certified engineers, materials consultants, those kind of costs. Next, for the operating costs, we have maintenance and we have replacement costs. Maintenance is the cost that occurs for every event. Replacement is due to corrosion. If you want to replace it, yes, there is a cost, of course, for the new component. So that is the replacement cost. So these 5 elements, if we add them all up, we get the total cost. Now, from this model, let's put carbon steel and stainless steel into the picture and see what sort of difference we have in here. And here we are. This chart shows the life cycle cost of a carbon steel electric bus and one for stainless. And by the way, this comparison is based on just for the bus frame, not for the other components, because we are dealing with bus frames now. First, I'll look at the left one. Let's look at the left one. This shows the cost for carbon steel. The material, yes, it is cheaper. Fabrication cost is there. The other installation cost is there. And we have maintenance and we have replacement costs. You add these 5 factors and we get a sum of 26,160 euros per unit. Okay? Now, on the right side, it has the same model for stainless steel. Material cost, yes, it is more expensive. Fabrication is there. The other installation cost is actually cheaper than carbon because if you look below, I wrote down what the maintenance cost is, and in this case, it is the difference of cost because of the painting that's applied. For carbon steel, we use 4 layers. In this model, we use 4 layers. And in contrast to that, in stainless steel, there's 2 layers of coating, painting. So there was a cost difference from there. Now, after that, we have operating costs, and in stainless, there is none. Because for the bus frame, we're using stainless steel, and if you use a bus for 12 years is nothing even close when you compare it to the lifespan of stainless steel. So there is no maintenance cost, there is no replacement cost. We add these up when we get a sum of 23,130 euros per unit. Compare to left and right, basic calculation, we get a 12% decrease of cost. And in this business environment, if you can get even a 1% decrease of cost, that's a huge thing. But if you get a 12% decrease, well, that's phenomenal. Now, one thing to bear in mind is that this comparison is different from the one that I mentioned earlier, with the one with diesel bus and electric bus comparison. That one was a comparison with what sort of bus it is. This one is a comparison of which raw material was used. So just to make sure no one gets confused on that aspect. Next, I'll go to the resale cost of this. Now, resale means that we use the raw material, we made a bus, we use it for the lifespan that we plan to use it, and then in the end, we dispose it. Now, since there's steel, we can recycle it. Now, let's do a comparison of the scrap price between carbon steel and stainless steel. And these are all actual figures, actual numbers from Far East listed prices as of last month. First of all, on carbon steel, on the left side, we have an original price of the mother coil for stainless steel. For carbon steel. We also have a scrap resale price. Now, if we do the calculation, the scrap reclaim value percentage is 26% for carbon steel. Now, on the right side, we have the same logic for stainless steel. Of course, there's also the same original price for the mother coil. And also, we have the scrap resale price, and the percentage is much higher. It's 59% for the scrap reclaim value. So, not from the very beginning, but also to the very end when you dispose the material, the amount of benefit, the benefit that stainless steel can provide to you is much higher than when you compare it to another material. All right, so with our electric bus, we'll use stainless. If we use stainless, where is it used exactly? And here's how it is. This is the production procedure for making the frame of an electric bus. And for a standard 12-meter bus, 1.8 metric tons of stainless steel is required. I want to note that this 1.8 metric tons was calculated on the basis that we use austenitic 304 and ferritic 430. I'll get to those grades a little later, but it was calculated on that basis. Yes, there are some other grades out there that are lighter, but for the sake of calculation, 304 and 430 were used. So if we have this raw material, how do we make it? Well, first of all, we get the welded stainless steel tubes. This is the base for a platform. We weld them to make the platform. We also make the roof panels. After that, the platform, the roof, the end panels, they're all welded out, followed by stainless steel sheets bonded together to finish the frame. And I want to add that not only the frame, but also inside the bus, for the floor surface, stainless steel checker plates, which I'm sure everyone has seen, they can also be used. And thus, we have our electric bus frame. So, if the electric buses are using stainless steel, then how much tonnage are we talking about? And this chart shows that. This chart has been made on the assumption that every electric bus in the future will use stainless steel. And if we convert that into tonnage, here's how it looks like. From 2020 until 2030, you can see that for the most part, the chart goes up. There's a constant increase of stainless steel consumption, with the exception of a couple of years in the middle. And that's because, as you can see, on a regional basis, China's consumption slows down a little bit. I mean, there's a reason to that, because as I mentioned before, they started 20 years before, in 2001. And as of 2019, already 23% of all buses in China were already electric. So because of that head start, the curve goes down a little bit for China. But in the meantime, the rest of the world kicks in. Europe, United States, rest of the world, they all kick in. So the consumption forecast goes up, which means that from a stainless steel supplier's point of view, this market certainly is something to note, something to consider. Excuse me for a second. Now that we've seen what sort of forecast we have in hand, where to go for these materials? And for that, we have our ISSF members. Now, these next three slides, they illustrate the steel grades that are available from the ISSF members. However, on accordance to our internal discussion guidelines, no discussion of prices, pricing terms, or any component of price is possible. The next slide will be shown to you to show a bird's eye point of view of what sort of grades are available for you when it comes to bus frame application. And actually, these grades are already used for bus frames, so keep that in mind. First of all, for the austenitic materials, we have 200 series and 300 series. 200 series is a class of austenitic stainless steels that are characterized by having a low nickel content. So one of the grades that you can use is 0.4371. It has high electrical conductivity. Now, for the 300 series, what is it? It's a chromium nickel alloy that achieves austenitic microstructure almost exclusively by nickel alloy. And by the way, 300 series is the largest group, it's the most common one when it comes to stainless steel. What do we have? Well, we have 0.4301, other known as 304, 18/8. It's the best known grade, it's the bread and butter of stainless steel, it's the most common grade. It has a chromium percentage of 18%, nickel 8%. And along with that, we also have 0.4318, which is a low carbon nitrogen alloy with elevated strength. It's suitable for lightweight construction, used for applications that require hardness and strength. Next, I'll move to the 400 series. For the ferritic, we have two grades that are available for you. And these are 0.4016, also known as 430. It's the 304 for the fabricated materials. It has good corrosion resistance with good formability and ductility. Next, we have 0.4003. This has excellent weldability, elevated yield strength, and has resistance to abrasion. And finally, we have duplex. Duplex, as I mentioned before, is a mixture of austenite and ferrite materials. It provides better corrosion resistance. Actually, it has the best corrosion resistance when you compare it to the other families, particularly in chloride stress corrosion and chloride fitting corrosion. So it has better performance when you compare it to 304 or 316. The grades that you can use and are actually already in use are 4062, 4162, and 4362. So these grades that I mentioned, they're already in use. Of course, which one are you going to use? It depends on what the manufacturer, what the customer wants, what your budget is, what sort of model you have. It all differs, but these are all options that you can select when you are manufacturing your electric bus. And if there's anybody in the audience who wants to have additional information about these materials, please inform us. We'll be more than happy to inform you with all possible information that we have on this. So that these grades are here, then where do we go to buy these? And for that, we have the ISSF members. Now, these members that are stated here, they are the suppliers that produce stainless steel, the mother coils. The tube manufacturing is conducted by other parties down the supply chain, but for the mother coils, here we are. And you can see that for pretty much everywhere in the world, we are here. Whether you're in America, Africa, Europe, or Asia, we're located everywhere. So accessibility to these materials will be no problem. If you have any specific requests for a specific supplier, you tell us privately, then we'll connect you so that you won't waste any time finding the right address. So this comes to the summary. Now, we've seen the greenhouse gas regulations that are coming into effect. We've seen that mass urbanization is taking place, causing another burden. Therefore, the shift from conventional diesel to electric bus is imperative to ensure sustainability. And with that in hand, electric buses have many advantages compared to diesel buses, whether it's emission, noise, or cost. So using a raw material with the lowest life cycle cost and the most desirable physical attributes will contribute for a smooth transition to a reliable and sustainable solution. So we have carbon steel, aluminum, stainless steel. Other than carbon steel, yes, aluminum can be used, and while it is light, it has limits in withstanding damage compared to stainless steel. And stainless steel, besides this, it has several materialistic advantages that we have seen. And when it comes to cost, the life cycle cost is significantly lower compared to carbon steel. So all in all, from today's presentation, you can see why these are needed, and when you are selecting your raw material, stainless steel can be your next choice. Now, this will sum up the presentation. I want to add that after this, there's actually several appendix pages to give some supporting data for those who are interested. For example, there are many people involved in this project. Besides that, we have statistics for the market forecast, what the Chinese government has been doing for the past 20 years, forecast for the stainless steel tonnage, a hydraulic press test for aluminum and stainless steel, mechanical property comparison with the materials that I've mentioned, and finally, the application that I mentioned before, made by SASTA, which is accessible by everybody, everyone can download it. So these are all available on the appendix. Once again, this data will be shared to all the registration folks and also be posted on YouTube so anyone can enjoy it afterwards. That will sum up the presentation. Should anyone have any questions, please write them down on the chat box and we'll answer them as best as we can. Should we fall short of time or should it be a private question, then afterwards we'll answer them via email, so no worries on that. Have we got any questions?
At the moment, we don't yet. Here's the first question. Seems like the market for electric buses in India is very low. Is there a specific reason for that?
There is one reason, and it has to do with infrastructure. As I mentioned before, if we look at the Chinese example, they had 20 years to prepare for the investment and the implementation of the basic infrastructure. Of course, every data has their own forecast, so it might be a little different on accordance to which data you're referring to. But the Indian market, the speed of which it is expected to grow is a little bit slower than we would like it to be because of the infrastructure element. We expect that it will take a little more time for the infrastructure to be installed in place. Only then can this electric bus market flourish even more.
Okay. The next question is not really about the frame, it is about the battery components, and I'm not sure whether we know the answer to that.
I mean, luckily, since we do have data with regards to the battery, of course, this presentation is not about that. If we have the question, so we'll respond to that via email later on.
Okay, so that question will be replied to via email. I don't know whether there are any other questions. We'll wait for a bit, see whether they are coming in, so people have time to type their question. Okay, is there a weight advantage using stainless?
With regards to weight, we come to density, and when it comes to density for the classical austenitic 304 or ferritic 430, when you compare it with carbon steel, it's almost the same with regards to weight. However, I won't mention the exact steel grade, but there are certain grades out there that can provide a weight deduction, despite the fact that it's the same model. For example, on the previous slides, I mentioned that 1.8, an average 1.8 metric tons of stainless steel is needed for each bus, 12-meter long bus. And there are certain grades that if you use them, you can shed a couple hundred kilograms from that. So, like I said, there are multiple options available. Of course, these grades, they might cost a little more, but depending on your preferences or where you put your importance on, yes, it can be a choice.
Okay.
Just add in, it's probably fair to say that the grades that offer that opportunity are the duplex family of grades, which, though they've been around for some 90 years, are less well known in the user community than in the producer community of stainless steel. So these are grades that are perfectly suitable if you want to lightweight your vehicles by some 20% or maybe a little more. They have much higher strength, much better energy absorption characteristics, and excellent corrosion resistance. So as Frank says, they'll cost you a little more, but at the end of the day, you'll get a lot of useful benefits. Of course, stainless can never match the lightweight of aluminium, but where it does outperform is in the field of both corrosion resistance, overall strength, and the energy absorption in case of impact or things like that, which we know occur in urban settings. So if safety is, and I would argue should be, your primary focus, there is no doubt that choosing a grade or type of material with high energy absorption properties is certainly, or should be, at the top of your list.
Okay, we'll move on to the next question. What percentage of buses are made of stainless steel at the moment compared to other materials?
stainless steel percentage. We actually have some preliminary data on that, but several countries in the world, they didn't publish the exact numbers. I will send to the person who wrote the question the data that we have on percentage of stainless steel bus frames as compared to the entire pie.
Okay.
Frank says Joe, I was just going to say, as Frank rightly says, it's very embryonic, that data, and is very low, but there are a few lighthouse cities, I should say. Shanghai, I think from memory, being one of the leading cities in stainless frames for electric buses, and there's a couple of other places as well. So there are some great examples, but it is still very much in the development and sort of early growth phase. We've not nowhere near reached maturity, as Frank's shown from the overall growth pattern expected for electric buses. So there's a huge opportunity here.
Okay. The next question is about the stabilized ferritic stainless steels. Why would they not be an option for the frame?
Oh, they are. They are. Like I said, there are several choices, and whether it's Ferritix 430 or other grades, they are in use. It depends actually on which region you're in, what the customer's requests are. For example, in India, many companies already use 409, Ferritic grade 409 for their bus frames. Some places they use 430, so they are in use. It's just that when it comes to corrosion resistance, it's more vulnerable when you compare with classical 304 or duplex grades. That's the only difference, but they are already in mass use when it comes to electric bus frames.
Okay.
I think just in addition to that point that Frank's made, ferritics can be considered, and certainly stabilized ferritics, as the question referred, but everything's a trade-off. You can't very often get all the desirable attributes in the same bag. So you might give a little on price to get more enhanced properties, or you go for a lower material price, but accept that some of the properties will not be in the sort of most optimal zones. So it will come down to what's right for the environment. But I think the main focus here is that whilst there are many different stainless steels available, they do, by and large, offer many advantages over competing materials.
Okay. The next question is a bit, what's the biggest hurdle to more use of stainless in electric buses? Would it be like to convince the buyers, train the fabricators, or what would be the biggest hurdle?
It depends on, of course, what preferences the customer has. But in our point of view, it's breaking the preconception of the budget. Usually when you have a new model for production, one of the first things that you consider is the budget, the initial investment cost. And as we've seen, on the life cycle aspect, yes, stainless steel is more advantage. But when you just consider the first cost that needs to be inputted for the production, carbon steel is cheaper. So companies naturally, they tend to think not on the long term, 10, 20 years down the road, but more of how much does it cost today? And because of that, that causes not only a financial, but like a psychological barrier in adapting stainless steel into their bus frames. So breaking that concept, that preconception of how much does it cost today, and widening it to how much will it cost me until I dispose this material, that I think is one of the biggest obstacles that we face in expanding stainless steel.
I think, and Frank makes some very good points there. I think one of the questions we should all ask ourselves is if we were responsible for not just building the bus, but running it and maintaining it, so one company does all those things, how would we think about this? And I suspect it's very different from the thought processes today, but that is the most optimal way to think about any assets of this nature. It's not build it as fast and as cheap as possible and then hand over all the problems to somebody else. To think holistically. Whole life cycle thinking is where we need to move to.
Why other installation cost of stainless steel is cheaper than that of carbon steel?
Yes, I will go back to that page. Hang on a second. There we go. With regards to other installation costs, I don't know if you can cursor here, but if we look below, it's mostly because of the result of painting. And because in the model that we used for carbon steel, the amount of painting required as compared to stainless steel, it has to be more. There's 4 layers in this procedure for carbon steel: surface preparation, primer, intermediate, coating. And in comparison to that, stainless steel had 2 layers, primer and top coat. This was the major reason why there was a cost difference for the same procedure. I hope that answers.
Frank, can I just add to that, because that's a very helpful answer to the question. But the other thing to remember, even though modern coatings are quite effective to prevent or resist corrosion, I think resist is the better word to use in urban applications, just the amount of debris that gets picked up starts to chip away at those coatings. So a lovely environment with no debris and no sort of urban pollution, a coated carbon steel will last reasonably long time. But once you start involving moving parts and churning up debris, you're into a very fast mode of failure of that or those coatings, even though you may have 4 layers, as Frank says. So it is a word of caution. Of course, ultimately the choice of material is with the manufacturer, but are you sort of opening yourself up for something that could be subject to future criticism, particularly when we are moving into this method of thinking of build and forget?
Okay, there has been a next question. What's your view on the use of composite in now and or in the future?
Composites.
Yeah.
Referring to
For the frame.
Do you want me to take that one, Frank?
Okay.
There is no doubt composites are developing at a phenomenal rate and have some very exciting uses. And I think we have to recognise that composites will be a competing material, not just against metals and alloys, but other materials in all applications. So these products are developing fast. They're not going to go away. They will have the benefit of lightweighting. But I think what we equally have to recognise is that when you're in an urban setting where people safety is of very high importance, the longevity of proof of keeping everything safe is probably not reached its full understanding yet for composites, and that will develop. But it is again something to consider, that if we do want to genuinely think safety first and foremost, and I would always argue that wherever you've been in your day, whether it be at home, at work, doing leisure activities, everybody has the right to go home safely. And we should always, in our choice of materials, have that first and foremost in our minds. So composites are here, but I still have some feelings that we've not reached the end of the development curve for those materials yet.
Okay, thank you, Tim. Next question. How big weight savings bus producers can get if they use duplex stainless steel compared to carbon steel?
It depends on the grade, as I mentioned earlier. I won't mention the exact grades that can provide weight savings, but there are certain duplex grades that can provide weight savings compared to the conventional 304 and 430. Of course, it costs a little bit more when it comes to the price tag, but it is possible. For example, I mentioned that 1.8 metric tons were required for the model that we use. In contrast to that, some grades can shed off a couple hundred kilograms from that weight. Of course, that all depends on what the supplier, what the customer wants, and how it fits their budget, but it is possible, yes.
Can I just add to that?
Yes.
We know already from some examples, 20% and upwards is achievable with careful grade selection. So this would require a bit of research work between bus builders and material suppliers where the technical expertise sits, but something of that order is definitely doable. And I think it's a good number, a good guide number to have in your head.
Okay. Then I think there was no further question for the time being. Let's see if anybody else is still maybe typing their question before we end this session. Wait one more minute. Okay. Now there's a specific question to what company is producing the duplex tubes. But I think that's a question we can answer later and send that particular person the list of those producers where you can get for the duplex tubes. Thank you for your question.
One more thing to add, we want to make sure that the folks that participate in today's webinar, they make the most out of it. So these questions are all very, very, very welcome. Anything of similar nature, please tell us individually, and we'll give you the answer. We'll provide you the answer as soon as possible, so all of your questions are answered. But once again, as Joe mentioned, we'll answer you to this in a private manner.
Okay. And then there's a question which relates that most of the time buses are replaced every 20 years. So why then do we want the frames to last for 40 years or even 50 years?
Well, it's all because of the price. And here's the thing, with regards to buses, if we ride a bus, I'm sure that everybody has experienced it. The buses that we ride, they're not here for short term. They're actually here for as long as the bus company can operate them. The purpose, the objective of the bus is not on anything else, but the primary objective is to make the bus execute its objective, and that is to transport people. So what happens is that from their perspective, as long as it doesn't look terrible and it functions the way it should, they will keep on operating it. Thus, that means that the lifespan for the bus will be longer than what people normally think of. And I gave an example that it was 12 years, but actually in other parts of the world, it's much longer than this. There's buses that have been here for more than 20 years. And the reason is because it functions as a bus. So because the operators, the final customers, they want to use this as long as they can, that means that on financial perspective, beneficial for you to use a raw material feedstock that has a longer lifespan, is more resistant to corrosion, and thus that leads to the conclusion of stainless, as we've mentioned.
Can I just add to that, because I think I would also argue that as a society, we've all been guilty of short-term thinking, myself included. And with something like a bus, if the basic structure of a bus is resilient and will last, let's say, even 100 years, you can change the interior rather much like you do in your home. You don't necessarily knock down your house and rebuild it every 20 years or something just because you can. You actually adapt things. And I think that's one of the themes that we should take forward in our modern society. We're not a McDonald's society, even though McDonald's have done their best to convince us that McDonaldization is the right way to go. We should think long term, and there's nothing wrong with that. We can still make things look modern and be appreciated by the users without changing the basic concept. And I think that's the argument here. Let's get into a different mode of thinking and not think replace, replace, replace. I know people will say, hey, that creates jobs. But what we're actually thinking about is creating jobs in a different way here. We're shifting from one way of thinking to another way of thinking without loss of employment opportunities. And that's really important for society. The notion of repair, repair, repair is old school thinking, I would argue, and that's a harsh and provocative statement, I know, and purposely said, but I think that's how we have to modify how we approach things as a society. I'd equally like to go back just briefly to the previous question about duplex grades. Duplex grades have been around for almost 90 years. But the problem we have with duplex grades is the user community is not so familiar with it. So these are not the new kids on the block. They've been around for a long, long time, and they're produced all over the world. But understanding duplex is often a little more tricky for people who want to venture in to this world where there are so many advantages. So again, if people want to understand a little bit more about duplex, Frank and I are happy to talk about those things separately, just to help people's understanding.
Okay, there's some questions about some specific grades which we can answer privately, and then we can wait for one more minute, see if there's any more questions, can't we?
Of course we can, yes. I think, you know, just going back to something that I said earlier, I think it's important that as we try to deal with all the dilemmas we have in the world, whether it be climate change, mass urbanization, anthropogenic forcing resulting in increased pollution, we have to take responsibility and think differently. So the old idea of just learning what was done previously and trying to make it a little bit better through constant iteration, I think is now something we have to well and truly abandon and go for another big bang change. Otherwise, we risk losing our planet. I think it's as easy to say as that. And it's time we all woke up and start doing things differently. And I think the China example of the sort of central planning in this presentation is a great example of where I know China have had some bad press on one or two things, but hey, you can't fault this centralized governmental approach to say we need to make this big shift, and that's really credible and very much appreciated.
Okay, I don't think there's any new questions coming in, so we can end this session.
All right. Well, thank you everybody for participating. Once again, these files will be shared with everybody who is registered. Thank you for your time. I hope it was beneficial, and I hope to see you on the next ISSF webinar. Thank you.
Thank you.
Thank you. Bye-bye.